Remember that from the for the particularly from the next assignment you have to submit it.
So where to submit the work?
Actually, when you go with the particularly page, your assignment page. Okay, so
Yes.
at the top of that one particular link is given.
Uh, okay,
Okay,
okay.
so click on that link and then upload your document, upload your work.
Another thing is that assignment 6,
Yeah.
question number 13. Can you just guide, not exactly this question, how to handle
Mhm.
this kind of problem?
Wait a minute, I just check it. Question number 13. Mhm. Week 6 and assignment. Okay. Okay, so I will go with this type of questions also. Anything else? Any doubt? Okay,
That
so
Sir, I have problem to determine the Boolean expression of multiplexer.
okay, you have a problem in the Boolean expression of multiplexers. Okay,
Also decoder.
sir, I have
How I express the Boolean expression
okay,
from the circuit or the truth level.
okay. So if we go with the Boolean expression, my screen is visible.
Yes,
yes,
sir.
sir.
Okay. So the thing is that, like for example, we have a um, select line to select line S0, S1, and the output Y. Okay. So when S0 and S1 both are S1 and S0 both are zero, I am taking a 4 cross 1 mux. Okay, I0, I1, I2, I3, S1, S0, and Y. Okay. Now if S1 and S0 both are 0, so initially the first input is connected with the output. So Y is I naught. Okay. Now if we are taking the S1 is 0 and S0 is 1, the second input is connected I1. If it is a 1 0, I2, and if it is a 1 1,
Yes, sir.
I3. Clear? So this is the working of the multiplexers. Now how we write the equation, like for example, if I naught is available. So if I write the expression for this one, so I naught S1 and S2 are the on the basis of that one, it will be it will be decided that it is I naught. And what is the value of S1 and S naught? 0 0. So I just mark as a S no S1 S0. Okay. Now for this one, if I write I1 again S1 S0 and value of S1 is 0, so it is a S1 bar. If I2 S1 S0, what is the value of 0 is 0, so S0 bar. If it is I3, so
Okay, this is
I3
like mean term.
S1 S0. Yeah, mean term.
This is
Mean
like
term.
mean term, yes.
Yeah, exactly. Okay, now the mux, what mux do?
And
Mux will be combine all the inputs. Mux will be combine all the inputs. Okay, so overall y expression is what? The addition of all terms, all in outputs. Okay, output because of I naught, output because of I1, output because of I2, and output because of I3. So if I combine all those, it become a S1 bar S0 bar plus I1 S1 bar S0 plus I2 S1 S0 bar plus I3 S1 S0. Okay. Now according to the value of I0 and S1 and S0, automatically we are giving the Y that we require. Okay, like if I select a S1 S0 is this one. So S1 is 1 and S0 is 0. So S1 is 1, so S1 bar is 0. So 0 multiplied by everything is 0. Plus again S1 bar, it becomes 0. Okay, plus this becomes 1. Now S0. S0 is what? 0. So S0 bar is 1. Plus S1 is 1 and S0 is 1.
okay, I understand this.
Okay. So that's why you are getting the
Yes.
correct output. Okay. So we combined all the data and according to this one.
And sir, what is for the decoder?
Decoder, I will go. I am not explaining the decoder till now. We are cover that mux and demux in the previous class. I just go the decoder part. Okay. Any doubt in the
Okay, sir.
mux part?
No, sir.
Sir, that question number 13, sir.
Yeah, I will explain. I will explain
And sir, one more doubt is there.
that.
Can demux can be used as a mux?
No, the working of demux is different and the working of mux is different.
And can mux
Mux,
can be used as a demux?
no,
Actually, I asked someone. They said yes. You explain if it is a question is correct. Can demultiplexer can be used as a mux?
the demultiplexer can be used as a mux.
Yes, sir.
How is it is possible? Like for
I
example,
don't know. They
okay,
said you think it and let me know.
okay.
It's not came in mind how to utilize. I mean, how to answer this kind of questions.
If there is no gates is available, so we can't use that one. If the gates is available, we are giving our data in a way that all combination possible that as in the output will be added. Like for
Uh,
example, if I am using that, okay, if in the place of I naught, what should I do? I should just mention the I naught S1 bar
Sir,
S
but
naught bar.
we can use decoder as instead of mux, no, sir?
Yeah, we can use the decoder. Different decoder and mux is different options, but mux and demux, mux working is that it will be combined, and demux working is that it is again a separate.
Okay, sir.
Okay.
One doubt is that decoder can. What is the decoder has for a 3:8 decoder? The
I just
output
go with
is
the decoder part. I just go with the decoder part. That is, we can initially
okay.
clear the doubt of the mux. After that, we go to the decoder. Then we relate the decoder and mux.
Okay, sir.
Okay.
so the answer is no, sir.
No.
Okay, sir. Thank you, sir.
Okay. Now, if we go with the question, like for example, I have to implement sigma m 0, 1, 3, 4, 6, 7. Okay, that is a y a b c. Okay, y a b c. Now what should I do? I have to design this particularly with the help of 4 cross 1 mux. That means 4 input is available, 2 select line is available, and 1 output is available. Okay, 1 output is available. Now in this case, what I do, it is up to me that which particularly I am using as a select line and which particularly I am using as the input part. Clear? It is up to me. Like for example, if I use that A will be my input part and B and C is my select line. Okay, so when A is 0, when A is 1, now possible solution for BC is 0 0, 0 1, 1 0, and 1 1. Okay, now where the terms are defined, terms is 0. So A, B, C 0 0 0, that means here the term is defined. Then 1, 0 0 1, here term is defined. Either I can use 0 or either I can use a 1. That is up to my notification. There is no particular. Or I can just mention that here the term is defined. Here the term is defined. Now 3. A is 0, B and C is 3. So here the term is defined. 4. Here. Okay. 6. 6 is 1 1 0. So here the term is defined. And 7. Here the term is. Clear? So we map on the basis of select line and input. Any doubt?
So just like K-map?
Not a K-map, not a K-map. In the K-map, we use the gray coding, but here we are not using the gray coding.
Okay, sir.
Okay, we are using the select line. So A is my input. Okay, if I say that A is my input, so there is no particularly effect of this one. Only I am considering BC. If BC is 0, that means this is the, I take that it is a B and it is a C. Now the possible values for BC is 0 0, 0 1, 1 0, and 1 1. Okay, if BC value is 0 0, so which line is selected? This line is selected. Okay, so if I say that it is I0, I1, I2, and I3. So if BC is 0 0, so I0 is selected. If BC is 0 1, I1 is selected. If BC is 1 0, I2 is selected, and if BC is 1 1, I3 is selected. Clear? Now, what is the value we are connected at a I1?
Sir,
I0.
sir,
Yeah, yeah.
in this question, B and C are the select line. A is the input.
B and C are the, you have A as the input.
Sir, only one input is there, right? A only.
Sir,
So do we have to care about I1, I2, I3?
Yeah, bilkul, that's
sir.
only one. Yeah,
So what I understood is input side, we are just writing the input combination only, right?
yeah.
And B and C and B and C. Okay, okay, got it, sir.
Okay. Now what we connected when a I note. Okay, when I note is selected. So if you see that on the I note, two terms will be defined and that terms is available in the question 0 and 4. Okay, if both term is defined, we can say the I A is 0 and A is 1. Both will be defined. So what should I connect? I connect it as a 1. Okay.
Sir,
Yeah.
You take sir 4 bit. Sir. 4 bit means input you take 2 bits, sir.
Where I am taking the 4 bits? I am
Sir,
taking only
yeah,
the 3 bits, na A, B, C.
no, sir. I mean to say, uh,
Can I explain this one? Then after that you ask the question. It is better.
Okay, sir. Okay, sir. Okay, sir.
Okay.
Okay, sir.
So when BC is 0, 0, so we select the I naught, and what is the value of I naught we connect here is that if both terms will be defined, we connect as a 1. Okay. Now
So
when
can you
0,
explain
1,
again this thing?
can I explain it? After that you can ask the question. I just
No,
repeat it
sir.
again. I just repeat it
What
again.
you said right now? Can you explain it again?
Yeah, I just explain it again. Wait a minute. Okay. So when what I do, I just select that which is my input and which is my select line. Okay. So I just consider BC is my select line. On the basis of BC, 4 possible combination is available: 0, 0, 0, 1, 1, 0, and 1, 1. Okay. Now what should I do on the basis of the value of A is 0 and A is 1? I am just marking that if BC is 0, 0, so 0 will be marked here, 1 will be marked here because it is available in the mean term question, 3, 4, 6, and 7. Clear?
Yes, sir.
Now I created like that. I just check that when BC will be defined, when BC is 0, 0. So the value of A is 0 and value of A 1 both will be considered.
Yes, sir. Yes, sir.
Okay. So if I
Yes.
combine these two, so I can write that the value of A is defined and value of A is 1 and 0 both are defined. So A plus A bar,
Yes. Yes.
and the A plus A bar is 1. So what should I connect here at I naught? 1. Okay. If I am using 0, 1, so at 0, 1 the A is 0 is defined, so I can mark as a bar. If I am talking about the 1, 0, at 1, 0 A is 1 is defined, so I can use as a. And for 1, 1 again, for this
A
term
plus A bar.
A bar, and for this term A, so A bar plus A. So I just mark as a 1 A bar, A, and 1. Okay.
Okay.
Now if I solve this one, so my y, what is y? Y is nothing but B bar C bar multiply with I naught. I naught is 1 plus B bar C I1. I1 is A bar. Okay. Plus B C bar I2. I2 is A. And last one is B C I3. I3 is 1. Okay. Now again if I simplify, so can I write A1 as a plus A bar? So A plus A bar B bar C bar plus A bar B bar C plus A B C bar plus again BC. Again BC. Now I can write A plus A bar. Okay. If I furthermore simplify it, so it becomes A B bar C bar plus A bar B bar C bar plus A bar B bar C plus A B C bar plus A B C plus A bar B C. Okay. It is what? 4. This one 0, 1, 6, 7, and 3. These terms are defined in question.
Yes, sir.
Okay. Now the thing is that I just choose that B in place of B and C is the select line. I just choose that A and C is my select line. Okay. So I just choose that A and C is my select line and B as a input. So the value of B is 0 possible, value of B is 1 possible. Now if it is a 0, 0, 0, 1, 1, 0, and 1, 1. Okay. Now if I combine, so at this point the value is 0, A is 0, B is 0, and C is 0, so it becomes 0. So 0, 0, 0. So 0, 0, 0 is 0. Term is defined. So I just mark as a x. Okay. Now for this position coordinate is 0, 0, 1. That is 1. Available in the question, mark as a x. Okay. For this position, the coordinate is 1, 0, 0. 4 available is here. Okay. For this position, 1, 0, 1. 5 not available, so leave it. For this position, 0, 1, 0. 2 not available, leave it. For this position, 0, 1, 1. 3 available in question, mark it. For this position, 1, 1, 1. 1, 1, 0. 6 available. And for this one, 1, 1, 1. 7 available. Okay, any doubt how we mark
Yes,
this
sir.
actually?
Sir,
Yes.
so you take input two variable, no?
Yeah, I just take a input as a one variable, select line as two variable.
So you take input as a two variable, then how to here because 0, 1 is there, so we are writing. If you take
Yeah,
input two variable, then four possible combination will be there.
yeah, four possible combinations were there.
Then how to matlab,
Again,
how to write?
yeah, okay, I will do that one also. Wait a minute, just can you clear one variable, one input?
Yes, sir.
Then we go to the next part, na? Just hold on. Okay. Now, can we mark for this particular position what is my position? What is my value is b bar.
B bar
For this one,
1,
1. For this one,
1,
1. For
B.
this one, b. Okay, so can I create my marks? 4 cross 1, where A is the select line, C is the select line. At I0, I just connect a B bar. At I1, I connect a 1. At I2, I connect a 1. And at I3, I connect a B. Now the finally output is Y, A, B, C, that is equal to summation M 0, 1, 3, 4, 6, and 7. Okay.
Sir,
According
I
to
have
this
a
one, I
doubt.
can choose my C as the input. Yeah.
Sir, how are you writing those to be one and B and B? Well, it's like I didn't study the whole thing. Like I
Yeah.
studied to decoder part, so
Okay.
I haven't studied the demultiplexer and multiplexers. So
Okay.
can you explain how you are writing this one B and B bar? It
The
seems to me that it
particularly,
is like a
yeah.
Carnot map.
No, not there. The term is defined. Okay. So when A and C is 0, 0, so that means the which particular select line is selected? I0. Okay. At the I0, only the term B not B is equal to 0 is defined. So can I write as a B bar?
The
Sir,
screen is
actually your
gone.
screen is not visible.
My screen is not visible.
Yes,
Yes, sir.
Please check your internet connectivity because from
No,
my
sir.
end,
Everybody, I think.
Just
Have
few
to.
minutes back it was working. Just now it has gone, sir.
No, sir, it is visible.
now I stop sharing and share it again, but I think so it is visible. Now it's fine.
Yes, sir. Now it
Yes,
is
sir. Now
visible,
it
sir.
is visible.
Okay. So at this particularly value when A and C both are 0, 0, so I0 is I0 will be selected as the output. Now what is the I0 value? If at I0 value only B is equal to 0 term is defined, and in the SOP what is the B is equal to 0 means B bar.
B bar.
Okay. When select line 0, 1, I1 is selected. I1 is selected as the output. Now at this particularly position B is defined as well as B bar is defined. Why B? because b is one term is available, b is equal to 1. So b is defined, and b is equal to 0, that means b bar term is also defined. So b plus b bar is 1, so I should mention connect as 1.
Okay.
Okay,
And it
now
is
again for the 1010 I2 is selected as the output. Now for this particularly position, again the b bar is defined and b is defined, so b plus b bar is 1.
okay.
So I connect I2 as a 1. For the 1 1, I3 is as a connected as a output. Now if we
Yes.
go with the I3, so b is equal to 1 is defined, so I can mention as a b.
Okay.
I can
Got
accept
it,
yes.
sir.
Okay.
Yes.
Now according to similar way, you can check that if C we select as the input and then A and B connected as the output. Okay, so if we say that C as a input, C is equal to 0, C is equal to 1, AB as a select line 0 0 0 1 1 0 and 1 1. Okay. Now 0 0 0 defined, 0 1 0 2 not defined, 1 0 0 4 defined, 1 1 0 6 defined, 0 0 1 defined. Okay, 0 1 1 3 I think defined, 1 1 0, oh sorry, 0 1 0, sorry, 1 1 1 0 0 4 defined. Okay, 1 0 1 5 not defined, and last is 7 defined. Now this one, what is the value of this one? 1 1.
Because
For
these are C
this,
plus C bar. That's why.
yeah, C and C plus C bar.
Yes.
Okay, for this one, C. Why? Because C value is 1. For this one,
C
C is
bar.
equal to 0, so C bar. Okay, now I use this particularly. So I use the A and B as a select line. Here I connect a 1, C, C bar, and 1. Okay, but remember that you choose that you can't mesh up that we connect one as a one from there and one C bar from there. If it is a I naught is 0 0. Select line is 0 0, then I naught is selected. So at this point we have to connect this one. Okay, only thing is that you have to remember this thing only. Clear?
So, sir, any three of these are valid, right?
Yeah, all three are the same circuit. Same output will be given.
So basically, we can implement in any one of them.
Yeah, exactly.
Okay.
Now clear?
Yes, sir.
Okay. Now, if the problem is that if four basically terms are available and we have to implement that one with the 4 cross 1. Okay, like for example, y is equal to y, a, b, c, and d. Okay, sigma m 0, 1, 4, 6, 8, 11, 12, 14, and 15. Okay. Any doubt? Any doubt?
No, sir.
No, sir.
No.
Okay. So we are taking a 4 variable. Okay. So that's why I
Yes, sir.
defined term up to the 15. Now we select 2 as a input line and 2 basically as a select line. So I think we can use we can use A and B as a
Sir, it's our choice to select the select lines. We should not use that formula of log to the base 2 and
what you are saying?
uh, like for the selected lines, we were using the formula of log to the base 2.
Yeah, yeah.
And so, like you, for the three variable case, you selected two lines and one input, no? So it is in our hand that we can use that as a 4 by 1 multiplexer or 2 by 1 multiplexer. It's not necessary that you can use that formula and go through that.
No. The formula is that if we are using a n cross 1 mux, the value of select line is log 2n. But okay, but this will not decide that if the 3 variable term is available or 4 variable terms is available or 5 variable terms is available. We can implement that one with the how many like 4 cross 1, 8 cross 1 or 16 cross 1 depending on the possibilities.
Okay, so that is a different topic.
Okay, yeah, the thing that is if we are talking about the n, yeah, like you are confusing with the small n and capital N. If we are talking about the n, small n is the number of bits. Okay, and this capital N is a basically size of multiplexer. Both is different. Okay, this is small n is
Okay.
never related with capital N. You can, if you have a like 4 variables, you can't say that you can use a 4 cross 1, 8 cross 1 or 16 cross 1. That is all up to you. Clear?
Yes, sir. Clear.
Okay. Now the thing is that if we are going to implement this 4 cross 1, so there are two ways. Is that one way is we can use two particularly 4 cross 1, like 1 4 cross 1 and second 4 cross 1. This is the one way. Okay, that is a very simplest way form. The second thing is that if we are going to implement a 4 cross 1, so we are taking a 2 as an input variable and 2 as a output variables. So let I consider that A and B as a input and C and D as a output. So the possible solution is 0 0 0 1 1 0 and 1 1. Similarly, CD is 0 0 0 1 1 0 and 1 1. Okay. Now we define that which terms are defined. So A B C D 0 0 0 0 0 0 1. 4 is 0 1 0 0. Okay. 6 is 0 1 1 0. 8 is this one. Okay. 11 is 1 0 1 1. 12 is 1 1 0 0. 14 is 1 1 1 0 and 15 is this one. Okay. Now what we do here is that If I design.
Sir,
Yeah.
here AB is a select line or what, sir?
AB we are taking as an input and CD as a select line.
Okay, AB as a input. Okay.
Okay.
Okay, sir.
Now, if all four terms are defined, we are considering as a 1. So that means if C and D are 0, 0, so it becomes 1. Okay. Then it is a 0, 1. In the 0, 1, it will be defined. AB. Okay. So can I write this one for this one is a A bar, B bar, or we can say the A plus B bar. Okay, so what I do, I just use a to input A and B, implemented NOR gate, and use this one. Clear? Any doubt? You can ask if you have any. If you have any doubt, you can ask.
So why is there this NOR gate?
This NOR gate is that if we are define the 0, 1, so that means my CD line is 0, 1. Okay, so for CD line, I have to connect I1, and what is the output I1 I have to connect? It is A and B, both are 0. So for this one, if I define the term, it is a bar dot B bar.
Yes, sir.
Okay, so A bar dot B bar is what? A plus B whole bar.
Yes, yes, yes.
So we are giving the A and B and NOR gate of that one. Okay, now
Can we directly give A going to a NOT gate and B going to a NOT gate and then taking the AND
OR
gate.
AND gate, yeah, you can took that one also. So it become a simply the NOR gate.
Sir,
Okay.
I1 is A bar, B bar, no?
I1 is A bar dot B bar, yeah.
B bar, B bar. And okay, so it's just a
So in case of
simplification, right?
Simplification. So I just use a bar B in place of A bar B bar. I am using the A plus B whole bar.
Okay, sir, got it, sir, got it.
Okay. Now for
sir, in
I2,
case of 4 variables or in variables, how do we decide the size of the mux?
that is all up to you. If it is not given in the question, you can use a 16 cross 1, 8 cross 1, 4 cross 1. Okay.
Okay.
But thing is that it is all up to you. But if it is given in the question that you have to implement either a 4 cross 1 or can implement as a 8 cross 1. So I just show you both cases. Okay. 4 cross 1 we are taking initially, then we go to the 8 cross 1 also.
Okay, okay.
Okay. Now this one for I2 is that one when C is 1 and D is 0. So when C is 1, D is 0. So these two terms are defined. Now if we are talking about these two terms, so here for this one it is a bar B, and for this one it is a B. So can I write as a B only?
Yes, sir.
Okay. Or we can check that if with respect to this one and with respect to this one, A bar is defined and A is defined. So when A bar and A both are defined, B is 1. B is 1 for both cases. So I just mentioned as a B multiply with A plus A bar.
Okay, okay.
Okay. So at the thing we are added a B. Okay. Now when C and D both are 1, C and D both are 1. So these two terms are defined. Okay. Now it is a, if you see from here, A is 1, A is constant and that is 1, but the value of B is 0 and 1. Value of B is 0 and 1. So can I write as A B plus B bar? Or simply you can write a both terms. For this one the term is A B bar, and for this one the term is A B. So if I take A as a common, so it becomes a B plus B bar. So what should I mention here? A Y. Okay.
Yes, sir.
Now we cross verify this particularly. So if I draw this one, now I verify that we are getting the same mean terms or not. Okay. So what is the equation for this one? Y is C bar D bar dot I naught. Okay. Plus C bar D dot I1 plus C D bar I2 plus C D I.
Now I naught is 1 and I1 is A plus B, A bar plus B bar.
Yeah. So I naught is
And
1. Okay. I1 is
A plus B whole bar.
I just mentioned A bar B bar.
Yes, sir. Yes, sir.
Okay. I2 is
B,
B.
I3 is A.
Okay. Now we convert into the standard form. What is the meaning of standard word? That means every term consists all variables. Every
Yes,
term
sir.
consists all variables. So I just convert into the
A
standard form.
plus A bar.
A plus A bar, B plus B bar, C bar D bar plus A bar B bar, C bar D. This one plus
Yes,
this
sir.
term is A plus A bar,
C D bar B.
B C D bar. Okay, and last one is A B
B
plus
plus
B
B
bar
bar.
C bar. Okay, so with this one, I just create a equation. So A multiply with B is A B C bar D bar plus A multiply with B bar. So A B bar C bar D bar plus A bar multiply with B, A bar B C bar D bar plus A bar multiply with B bar, A bar B bar C bar D bar. Next term is A bar B bar C bar D plus next term is A B C D bar and A bar B C D bar, and next term is A B C D A B bar C. Okay,
Yes, sir.
now it becomes
And then we check for the mean terms, the number
12,
of mean terms.
8, 4, 0, 1, 14, 6, 15, 11. So 0, 1, 4, 6, 0, 1, 4, 6, 8, 11, 12, 14, and 15. Okay,
Yes, sir.
so your answer is
Sir,
very correct.
can you explain how you are writing these mean terms so fast?
Uh, how I write this mean term so fast?
Like, are you imagining that A, B is 1 and 1 and C and D, C bar and D bar is 0 and 0. So 1, 1, 0, 0 is 12. That's how?
Yeah, the SOP what we consider that A is 1 1 0 0. So it is a 12. So in this one 1 0 0 0 8. This one is 0 1 0 0 4. This one is 0, 0, 0, 0, 0. This one is 0, 0, 0, 1, 1, 1, 1, 1, 0, 14, 0, 1, 1, 0, 6, 1, 1, 1, 1, 15, 1, 0, 1, 1, 11. In SOP, what we consider that if A bar is, that means the value is 0. If A is, the value is 1.
Yes, sir. Thank you.
No?
So it was just cross-verifying the demux.
Yeah, your mux is correct or not.
Okay.
Okay. Similar way, if I want to create Y, I just take one more question. After that, we start a decoder part. Sigma M 0, 1, 5, sorry, 0, 1, 3, 4, 6, 7, 10, 12, 13, 15. Okay. Now I just choose that CD is my input and AB is my select line. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. Remember one thing is that we can't write the code similar to the KMap. KMap is different thing. In the KMap, the grouping between these two will be possible. The grouping between these two is possible. But here
Yes,
not
sir. Yes,
this,
sir. Yeah,
this particular
remember.
group. Okay. So just
Yes,
remember
sir.
this one. Don't be confused with this KMap grouping and basically this one. Okay. Now 0. So 0, 0, 0, 0. Mention here. 1. A is 0, B is 1, this one, this is 4. 4 is defined, yes, 4 is defined. The value of this one, A is 1, 0, 0, 0, 8, not defined. This is the 1, 1, 0, 0. 8 or 4, 12, defined here. Now 0, 0, 0, 1, 1. 0, 1, 0, 1. You just remember that why how we calculate this one, how we taken this one. Your sequence is A, B, C, D.
Yes,
Okay,
sir.
your sequence is ABCD. So first consider 0, 1, then 0, 1. So it
Yes, sir.
becomes
Yes,
a
sir.
0, 1,
That I
0, 1,
got.
5.
That I got.
Okay, not mentioned. Now A is 1, 0, 0, 1, 9, not defined. 1, 1, 0, 1, 8, 4, 12, and 1, 13, defined, mention it here. 0, 0, 1, 0, 2, not defined. 0, 1, 1, 0, 6, defined here. 1, 0, 1, 0, 10, define here. 1, 1, 1, 0, 12, sorry, 14, 1, 1, 1, 0, 14, not defined. Okay, now 0, 0, 1, 1, 3, define. 0, 1, 1, 1, 7, define. 1, 0, 1, 1, 11, not defined. And 1, 1, 1, 1, 15, defined. So 8, 14, 0, yes, 15 terms, 10 terms are defined. Now create a group. Now create a group. So here the group is created. These three. So can I write the equation for these three is C bar D bar plus C bar D plus CD. Okay. When I solve this one, so it becomes a D because C plus C bar is 1 plus C bar D. So when I solve this one, again apply the A plus BC, so it will be C bar plus C. Okay, so I naught is C bar plus C. When we go with the I1, so I1 is what? Again define a term C bar D bar plus CD bar plus CD. Again from this one C plus C bar D bar. So it becomes C plus D bar. So C plus D bar. Okay. For this one, it becomes only one term is available, so it becomes a CD bar. Okay. And similarly for the last one, it is similar to the first one. So it becomes a C bar plus C. Can you create a thing? Yes. The first term is C bar plus D. So what should I do? I just take a NOT gate. So C, it is a C bar, and sorry, C bar, and D using a OR gate for this one, and last I0 and I3. Okay. At the I2, we are taking a C, we are inverting the D bar, and ending these two. Okay. Now for I1, we are taking a C. Similarly, we are taking a D bar. Both are already available. Use only OR gate. Use only OR gate. Select line is A. Okay. Now any doubt?
No, sir.
Sir,
Yeah.
can you just give the questions?
Give the question.
Just go up, sir. Previous
Okay.
page, starting page. Yeah, yeah. Input I need to check. Input is 1, 2, 3, 6. Sir, here you have taken input as a 10. Sir,
Input 10.
just make me if I am wrong. The mean term given is 0, 1, 4, 6, 8, 11, 12, 14, and 15, right?
0, 1, 4, 6, 8, 11, 12, 14, 15. Okay. So
So
it is
it
a
is
0. It is
it is
1, 4, 6, 8, 11, 12, 14, and 15. Four, five, six, seven, eight, nine, 10. Yes.
yeah, there are 9 input are there, right?
Nine terms are available. No? 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 cross 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 terms are available. 1, 2, 3, 4, 5, 6, 7, 8, 9.
No, yeah, that's okay, sir. My doubt is uh, whether
This
you
is a
take
different
AB as
question.
a
This is
select
a
line or
different question.
CD as a
This is a different question.
no, sir. My doubt is
Hmm.
AB in this question, AB is the MSB, right?
AB is the MSB. Every time the AB is MSB because you see this one. This shows the which one is the MSB and which one is the LSB.
Leftmost is leftmost is MSB.
Yeah, exactly. If I mention it one here as a C, D, C, B, A, so now D and C, D is the MSB and A is the LSB.
If instead of 9, if it is a 8 also, then also procedure will be same, sir.
If it is a 9 in place of 9,
I mean, there are 9 mean term in this question. If there are only 8
either it is a 1 mean term or it is a 10 mean term, the procedure is same, na? What is the meaning of that one? That how many terms are there? Like we are using here the 10 mean terms. So the procedure is same.
Okay, sir.
It is not dependent on the mean terms, na? It is dependent on how you design this one. Either it is a 1 mean term, 2 mean terms, or 4 mean terms, or either we can go with the 15 mean term. The procedure is same.
Okay. And
Okay.
one more question, sir. POS
Yeah.
and SOP both are always complement to each other.
No. How can you say that one?
Okay. I mean, if max term is given, so directly we can write mean term, right?
Yeah, we can write a mean term, but they are not complement. The thing is that.
Okay. For a given
If
we can write mean term.
if
Okay, sir.
if a two variable term are available, I just say that sigma m 0 and 2. Okay, so I can write as a pi m 1 and 3. So 0 and 2 is
Got it.
0 and 2 is 0 and 2 is what? A bar B bar plus A B bar. Okay, now if I write in the POS form, so it becomes 1. 1 is what? 0 1. So it is A plus B bar, and third is A bar plus B bar. Now if I multiply these two, so A bar is becomes a 0 plus A B bar, okay, plus A bar B bar plus B bar. Okay, the terms should be same. Is it clear? So we can't say that these are the basically complement or basically invert of these two. The representation is different. Representation in SOP and POS is different, but the terms will be same. Clear?
Clear, sir.
Okay.
Sir, in the previous question, which one is the
Yeah.
MSB and which one is the LSB?
It is
Between
already
A, B,
defined
C,
in
and
this.
D.
Yeah, it is already defined. Na? If you see the sequence, so the left one is the MSB, right one is the LSB.
Okay.
It is given in the question. This one is the MSB, this one is the LSB. This is the representation. No? Okay.
Yes, sir.
Any doubt now? Any doubt?
No, sir.
Okay. Now the similar thing is that it is we design a 4 variable terms. I am taking the same question. Now, till now we design with the 4 cross 1 marks. But it is not, if in the question it is not given that you have to design with the 4 cross 1, it is up to you. You can design with the 8 cross 1 also. Okay, so same question I design with the 8 cross 1 also. Okay, so in the 8 cross 1, we required a 3 select line. So if I say that it is my 8 cross 1, 3 select line, Y I0, I1, I2, I3, I4, I5, I6, I7. Okay. Now it is up to you which you want as a select line and which you want as a input. So according to this one, can you give me any choice?
Maybe A, C, and D as select line.
A, C, and D. Okay, so B I am taking as a 0 and B as a 1. Okay, A, C, D. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1. Okay. Now,
Sir, one question. You were writing these things with in the sequence of gray code, right?
no, not in gray code. The same thing I repeat previously also. In this, don't be confused. Gray code will be used in KMap.
No,
Why?
okay, okay, okay.
Yeah, why? Because we have to create a group with this particularly, like we can create a group of this one
Yes,
also.
yes, got it,
Okay,
sir.
here we are creating the group in a column only.
Yes.
Okay, so we don't need any gray code for this one. Don't be confused. Again, I repeat, don't be confused with the where in this particularly we are not using any gray code. We are using simply
It's
binary
the
code.
sequence 0, 1, 2, 3, 4, 5 like that, right?
Yeah, 0 to 7.
Okay, sir. Okay.
Okay.
Yes.
Now, if it is a 0, 0, 0, B0, 0, 0, so it becomes 0. So I'm marking here. It become a 0, 0, 0, 1. So it 1 marking here. It becomes 0, 0, 1, 0. So 0, 0, 1, 0 is 2. No, not available. If 0, 0, 1, 1, 3 not available. 1, 0, 0, 0, 8 available. 1, 0, 0, 1, 9 not available. 1, 0, 1, 0. So 1, 0, 1, 0 is 10 not available. 1, 0, 1, 1, 11 available. Now we go with this one. 0, 1, 0, 0, 4 available. 0, 1, 0, 1. Okay, so 101 is 5 not available. 0, 1, 1, 0, 6 available. 0, 1, 1, 1, 7 not available. 1, 1, 0, 0, 8, 4, 12 available. 1, 1, 0, 1, 13 not available. 1, 1, 1, 0, 14 available, and 50. Now for this one, it is a B plus B bar.
Yes, sir.
So it is a B bar, it is a B, so it becomes a B plus B bar 1. For this one, it is a B bar.
It's B bar.
This one B. Now here no particular term is available, so we mark as a 0.
Okay.
If both will be cover, 1. If no particular term is there, 0. If one term is available, so according to the one term I can create. I can write. Now again, this one 1. This one no term 0. This one B, and this one again 1. So 1 B bar B 0 1 0 B and 1 A C and D. Okay, S2 S1 S0 A C and D. Clear? Any doubt? Yes, any doubt?
No,
So
sir.
similarly, we can do it with the 2:1 multiplexer. No?
Yeah?
Similarly, we can do it by the 2:1 multiplexer also.
The problem with the 2 raised to 1 is that if you have only one select line. So 1 is the select line and 3 is the input. So you required more number of gates initially before applying at the input part.
So it will become complex. No?
Yeah, it will be a little bit more complex.
So,
Okay.
but if they have asked to do
Yeah,
it
if
by
in the
2:1,
question I can say that it is possible. If given in the question, you can draw that one. No issue with that one. It is a complex, but if in the question they ask, generally we can do that one with the 2+1. But if it is not given in the question, so don't try that. We are giving a 3 bit as a 3 as an input and 1 as a select line. Either 2 and 2 or 1 and 3. That means 3 as a select line and 1 as an input.
And sir, by using 2:1 multiplexer, it meaning that 3 bit is for input.
Yeah, 3 bit is for input. And how we combine, like for example, the in the 3 bit combination, if we take a 3 bit, so there are the lots of gates as
Okay.
a,
So
for a
means
I node.
means sir 000 to 111.
Yeah,
Okay, sir. Thank you, sir.
okay, that is the input line. Now a similar thing, if I change this one, can I draw it here like my B is 0 and 1. Okay. Now input is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Now where it will be defined here, 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 don't define here, don't define again here, here, don't define again, don't here, here and here. Okay, now you have to create a equation for this one. Okay, so like for this one, the equation is a bar c bar d bar plus for this one it is a bar c bar d. For this one it is a c bar d bar and last one is the a c d. Now you have to use implement initially that one, and after implementing this, like if I say that it is a I node. Okay, so I have to implement initially this particularly with the help of gates. Now connect this particularly with the input I node. Yeah.
Yes, sir.
Okay, so we required a more number of gates. We required a more number of gates to
Yes.
implement as a input Y node. Now similarly for I1, we have to create a group of these all 5 terms. So it becomes a I1 is what? It is a bar c bar d bar plus uh, a bar c d bar third, then a c bar d bar, then a c d bar, then a c d. Initially we create these equation. Now this equation we connect as a I1 and B as a here. Then you are getting the same output. Okay, so before connecting the I node and I1 input, you have to implement this particular equation, so more number of gate are required, and this particularly become a complex. Okay, so that's why
Yes.
we prefer that either two input and 2 as a select line, and or a 3 as a select line and 1 as a input.
Okay. Sir,
Yes, sir, got it.
in this problem, can
Yeah.
you go for 4:1 again? Same problem, 4:1 you have implemented, no? Yes. Sir, here you have taken AB as a input and C and D as a select line.
Hmm.
So it's perfectly okay. And if you take C and D as an input and A and B as a select line,
Hmm.
then also there are 4 possible combinations 0, 0 to 1, 1, right?
Any possible combination, you can take any as a input or any particularly input as a select line. No issue with
Yes, yes,
that
yes.
one. You
Then,
have to
sir,
create a
how?
group. You have to create a group.
Yeah, then, sir, can you freshly write, 4:1, no? C and D as a input.
Hmm. You can try that one, na?
Sir, I'm
You can
trying.
try
I'm
that.
getting. Sir, I'm
Yeah.
getting some
Okay. Okay. So
confusion.
you are
Yeah,
getting a confusion. So
yeah.
you are selecting C and D as a input. Now can
And
you
A and
basically mark me 0, 1, 1, 0 and 1, 1, A and B as a select line 0, 0, 0, 1, 1, 1 and 1, 0. Now can you basically mark where the mark is available?
yeah. So now, if suppose if I want 4 means,
Where is the mark is available? You just try that one. Na? So where the mark is available?
sir, just you do 1 or 2, no? That is okay. You write 4, sir. Mean term 4. How you write?
This is the combination of mean term 4 is A is 0, B is 1, C and D both are 0, 0. So 0, 1, 0, 0 is the 4. So here I mark.
Okay. So
Your sequence, remember that your sequence A, B, C, D is always maintained. You can't
okay,
see that one, it becomes a 0, 1, 0, 0. You can't mark here. It is wrong.
okay. Yeah, this is only the confusion I was
Yeah.
according.
We have to maintain the mean term because which particularly input we are using as a select line, which input we are using as a input part. We can't change the order now. Order will be remain maintained A, B, C, D. That's it.
1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Sir,
Yeah.
where you have marks crossed, no? Below line is 5.
Where I mark below line is 5.
Exactly.
Yeah.
5
0,
is
1,
exactly below 4.
0, 1, 0, 1. 0,
Yeah,
1,
so exactly
0,
below, no?
1.
Exactly
5.
crossed.
Yeah, 5 here. If 5 is available
Okay.
in the particularly question, 5 is available here. But 5 is
Oh,
not a part of
yeah.
the question. So why should I
No, I
mark
mean,
here?
I just want,
Yeah.
yeah, I just for my curiosity, I want
Yeah,
to
yeah, yeah.
understand the pattern.
Okay.
Okay, and 7 will be 1, 1,
For
1,
this one,
1.
what is the value? For this one, what is the value?
This is a 16, sir. 15, sir.
How it will be 15?
Sir, which one, sir?
This one. This one.
Because, sir, this is 1, 1, 1, 1, no?
Why 1, 1, 1, 1?
Okay, sir. 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. Sir, this is 7, sir.
Yeah, 7.
Okay,
What is
now
the
I know.
combination? What is the combination of this point? This point?
1, 1, 0, 1, 1, 1, 0. 13, sir.
13. Okay. What is the combination of this point?
2.
2. A, B, 0, 0, 1, 0, 2. Okay, now clear?
Yes, sir. Now clear. Thank you so much, sir.
Okay, either you take any of the input as a select line, as any of the input as an input, or your sequence A, B, C, D will remain maintained. Okay, so particularly basically the value of that particularly point will be select a mark as A, B, C, D, calculate the decimal value, and that is the value of this column. Okay.
Okay, sir. Sir.
Yeah.
Sir, this live session is not available, sir. I mean, now it is available, but later on, suppose if I miss some live session, then is it
That
possible
is
to
available on YouTube.
how to find, sir?
I think anyone share the link. Maybe the
No.
link is already available on the portal. Okay, you can go with the Aniket will be In the chat box, the link is available.
Sir, if in this, sir, suppose if I miss some live session, no?
Yeah, every live session will be available on the same channel.
Okay, sir. Okay, thank you, sir.
Okay, shall we move further?
Yes, sir.
Now we go to the encoder and decoder part. So basically the encoder is what? For encoding purpose. This will be convert a decimal code to binary. Sorry, encoding binary to decimal. Okay. Now how it will be convert binary to the decimal? Sorry, encoding is basically decimal to binary. Sorry, decimal to binary. Now basically size of the encoder will be defined that if we have n input lines are available. Okay, if we have n input lines are available, output lines are available. So with respect to this one, 2 raised to power n is the input lines. Input lines. So if 3 output lines are available, we have a 8 input line, and the size of this particularly is called the 8 cross 3 encoder. Okay. Just any doubt?
No, sir.
Okay. Now the thing is that how it will be convert any decimal number into the binary. So like for example, I just define this one. There are the 8 lines. So I just mentioned that 8 line is I0 to I7. And with respect to this one, the Y0 to Y1, Y2 to Y0. Okay. So if I have a I7, I6, I5, I4, I3, I2, I1, I0 is available. With respect to this one, we are getting an output Y2, Y1 and Y0. So if I connect all input with 0, only one input is 1, I0. So with respect to this one, the output lines is 0, 0, 0. Okay. So for this binary, for the decimal 0 number, the binary number is 0, 0, 0. So it will be convert decimal number into the binary. If I use 0, 0, 0, 0, 0, 0, 1, 0. Okay, so it input high at the I1 pin. Okay, so basically what it will be do with respect to 1, it will be providing me the output lines position. So it becomes a 0, 0, 1. Okay. Zero 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 1 0 0. So 0 1 0 0 0 0 0 1 0 0. So it becomes a 0 1 1 0 0 0 1 0 0 0 0 0 0 1 0 0 0 0 0 0 1 0 0 0 0 0 0 and 1 0 0 0 0 0. So with respect to this one, 1 0 0 1 0 1 1 1 0 and 1 1 1 will be the output. Okay.
So can I explain it again? I didn't got it.
Again, explain it. Yeah.
Yes,
So
sir.
encoder what it do, it will be according to the which input pin is high, according to this one, it will be generate the output in a binary form. Like for example, if I say that I naught is 1, okay, so with respect to 0, what is the binary number? 0 0 0. It will be given the 0 0 0 as a output. Value of y2, y1, y0 becomes the 0 0 0. So that's why I can say the 0 will be converted into the 0 0 0. Okay. Similarly, if I say that I7, if the I7 pin is high, according to this one, the output is 1 1 1. So 7 decimal will be the 1 1 1 in binary number. Okay. So according to which pins we are putting as a high, with respect to this one, it will be show the output pins will be high in form of binary.
Okay, sir, got it.
Okay. Just decoder it the reverse. Decoder is reverse. In this particular case, 3 n input lines. So 2 raised to power n. So if we have n encoder, three input line I0, I1, I2. So we are getting a Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. Okay. So I2, I1, I0, Y7, Y6, Y5, Y4, Y3, Y2, Y1, and Y0. So if all three are 0, so only the Y0 pin is 1. If 0 0 1, Y1 pin is 1. 0 1 0, Y2 is 1. 0 1 1, Y3 is 1. 1 0 0, Y4 is 1. 1 0 1, Y5 is 1. 1 1 0, Y6 is 1. And last 1 1 1, Y7 is 1. Okay. Now clear? All remaining are 0, so I am not putting all are 0. Except this one, all are 0. Okay, so it is called binary to decimal. Okay. Any other doubts? Now we can create a decimal to the binary to the BCD code. Okay, so we can implement that one. If the mean term and max term is given, we can implement this one. Like for example, I just say my equation y is equal to sigma m 0, 1, 3, 5, and 6 is available. Okay, so can I write as m0, m1, m3, m5, and m6? Okay, and every term will be the adding because it is SOP form, so every term will be the ending. Now, where you get the m0? This is the m0. Okay, m1, then m3, then m5, and m6. Okay, now with respect to m naught, we are getting a y naught, so I use this y naught. With respect to m1, I am using the y1. With respect to m3, I am using the y3. With respect to m5 and m6, so y5 and y6 are available. Now if I o-ring y, because it is a SOP form, it is a SOP form, so all product term will be the summarized. That's why I'm using the OR gate. Now insert all particularly inputs. So we are getting a final output y. Okay, so this particularly decoder and encoder is used for the circuit mean term, maximum term definitions also. Implement mean term equation, implement max term equation, implement Boolean expressions.
Sir,
Yeah.
This question is y equal to m1356.
Mhm.
Sir,
Yes. The question is y is equal to 0 sigma m 0, 1, 3, 5, and 6.
okay. So input side, what I should write?
In the input side, we doesn't write anything. We define that what is the value of 0. Okay, at the 0, all particularly 3 inputs are 0, so that means this particular term is called as the 0. Okay,
Okay.
if we are
Okay.
giving,
So corresponding, I mean, if m0 is there, so corresponding output will be y0, and
yeah,
1 is there, corresponding output will be y1, and we are
yes,
adding. Okay.
yes,
Okay.
Sir, you
yeah,
have taken I2, I1, and I0.
mm-hmm.
Can I take I0, I1, I2?
I0, I1, I2. But initially, normally, generally, either it will be given in the question, that is okay. Okay, but generally, if it is not given in the question, so our MSB is what? It is a higher bit. Either it is I3 or it is I2, and the LSB is what? I. But if in the question it is given that MSB is your I0 and LSB is your I2. Okay, let's assume that it is given in the
Okay.
question. So what should I do? I just mentioned this I0, and I2. Okay. Now, according to this one, there is no change. Clear?
Sir, what you did?
If in the question it is given that MSB is your I0 and LSB is I2,
Okay, sir.
so we just only change this one,
Okay, sir.
but there is no effect of that. Okay.
Yes.
Any other doubts?
Sir, then diagram also will change, no, sir?
Why?
Because here you are saying I0 as a leftmost position, and in
Mhm.
diagram you are writing I0 as a topmost. So topmost will be LSB, no?
So now, okay, so you say that it is a I2
Yes, sir.
and this is
I2,
I0,
I1.
but we are not mentioning that this particularly is the MSB order or this is the LSB order. So either I just change it or it is I will not change it. There is no issue with that. Okay.
I'm asking, sir, you said I0 is LSB. If you are saying I0 is MSB,
Mhm.
then this diagram what you have
But
drawn is
but
correct.
but we are saying in the input side or in the output side.
Input side, sir.
Input side, either you change I0 I2 to I0. Okay. It is initially it is I0. Now it says that you are I2, and initially it is I2. Now you say that it is I. That's it. Now any doubts?
No.
Okay. So now in the question, if it is given that y a sorry y1 a b c d is sigma m 0 1 3 4 8 12 and 15, and y2 a b c and d is sigma m 0 2 5 8 12 13. Now you can draw it.
Two OR gates are required, sir.
Two OR gates are required. Okay, one for the I1 and one for the I2. Okay, so it is a simple. You can basically calculate which mean terms are available. According to this mean term, you just put a uh, taken this particular terms will be as a other. Now we can you create a binary to the BCD. Yeah, I take one example that I just want to convert as a binary to the BCD. Okay, so I just want to implement binary to the BCD. So in the case of binary, we required a 4-bit. I take a B, C as an input, y9, y8, y7, y6, y5, y4, y3, y2, y1, and y0. Okay, then y10 to y60, 50.
Sir,
Yeah,
you are saying binary to BCD.
yeah,
So BCD means binary coded decimal value.
yeah.
So 10 is there. That's why your input is 4-bit or any other reason, sir.
Yeah. If we are going to represent more than 7, we require a 4-bit. Okay.
Got it. Okay, sir.
Sorry, the thing is that so we required a binary to BCD decoder, not an encoder. A, B, C, D. It is a basically decoder. Okay. Now, what is the possibilities with the binary to BCD? The thing is that if I implement 0, 0, 0, 0, and y0 is 0, 0, 0, 0, 1, y1 is okay. Till 1, 0, 0, 1, the y0 is 1. Okay.
Sir,
Yeah.
the question is design binary to BCD. So how one should know whether I need to use decoder or any other circuit, sir?
If binary, that means the 4-bit is possible, and in BCD it is a 16-bit is available. Now, can you identify which is the encoder? We use the encoder or decoder?
No, sir.
Why so? If
Sir,
n is the
can you repeat question?
input, if n is the input, 2 raised to power n is the output bits, which particularly come with this circuit is what?
Sir, it can be demux also.
Demux, and that is the different thing, na? But I am not using the demux. I am explaining you the decoder and encoder now.
No, my
The
question is
question is
how.
now
Sir,
your question is that how we define that it is an encoder or decoder. Okay.
I mean,
Not
the question
you
you
are
are
not confusing. You are not confusing in the decoder and the demultiplexer. You are confusing in the encoder and decoder.
yeah. Oh,
Either you
anyway,
ask the right question is that how we decide that we use the demux
which
or
circuit
decoder.
is which circuit is we should use?
So
I
you
mean,
just ask the different question, na? Your question is that how we decide that we use the encoder or decoder. Now you define how we define that encoder and decoder. Any doubt where we use the encoder or decoder in this particularly combination? Now I go to your question part also, but please tell me either you define that it is an encoder or decoder.
it is a decoder, sir.
Decoder, how we say that one? Because if 4 bits are available, 16 output bits are as available. So if n
Yes,
number of bits as an input bit, 2 raised to power n is the output bit. So this
yes.
combination is called the decoder.
Okay, sir.
Okay. The second thing, your exactly question is that how we decide this, we design this one with a decoder or demux.
Yes, sir.
You are asking this question, but you want to ask this question, but you ask the different wrong question. Okay.
Yeah.
Yeah. Now, if we have to decide that decoder and demux, so it is given in the question.
Okay, sir.
Okay.
Okay, so got it.
Yeah. So first of all, and if we are talking about the encoder and decoder, so I just implement with the encoder decoder. The demux and mux part we have already covered. We are not going to club this one because it will be very confusing for you. Okay, just first cover the encoder mux demux, then after the encoder decoder, then we are going to combine these two. Okay, so just remove that we are using any particularly part of mux and demux here we are using now. We are not using any mux and demux. If we are going with the encoder decoder, we can explain only the encoder decoder. Clear?
Clear, sir.
Because I think your doubt is okay, but it will be panic for others. You are not taking the concept of the mux and demux in the decoder and encoder explanation. Is it clear?
Clear, sir.
Okay, so we are only talking right now encoder and decoder. Don't club with the mux and demux. We club them when everyone will be clear about the mux demux, everyone will be clear about the decoder encoder. Then we are going to club 4. Otherwise you will get confused. So don't club these two. Okay, so now what is the concept is we have to implement the binary to BCD. So we required a 4 cross 16 decoder. Okay, now the problem is that in the BCD 0 to 9 is represented. Okay, now in 0 to 9 4 bit is required. Okay, and the problem with the 4 bit is it will be implemented from 0 to 15, but 0 to 9 is the BCD number. When it goes 10 to 15, it is an invalid state. Invalid for BCD. Clear? Yes? Anyone? Any doubt? Just any doubts?
No, sir.
Okay. So what we do is that if A, B, C, D varies from 0, 0, 0, 0 to 0, 0, 0, 1 up to the 1, 0, 0, 1, Y0, Y1 up to the Y9 will be high. Y9, Y8, Y7, Y6, Y5, Y4, Y3, Y2, Y1 and Y0. Okay, but what will be going when we 1 0 1 0 will be applied? Okay, 1 0 1 0 will be applied. So when 1 0 1 0 will be applied, I think that what should we display in the output? We should display all values will be 0. Okay, that means it is an invalid condition. All outputs will be 0. That means it is an invalid conditions. Is it clear?
Yes.
Okay, so now if we go with the for this is not for the 10, it is for 10 to 15. 1 1 1 1. Okay, so what should I do?
Sir,
Yeah,
0 to 9 is covered, and for 10 to 15, you are writing 0. Why it is 0?
which particular circuit we are designing?
Binary to BCD.
What is the meaning of BCD?
Binary coded decimal value.
How many particularly values will be defined in the BCD terms with the help of 4 bit?
16.
Power 4.
For the BCD, 2 raised to power 4 is possible, 16 values is possible,
No, sir, only in up to 9.
up to 9. Now when we are going to do a 10, what will we do? For the BCD, it is an invalid state.
Yes,
Yes,
sir.
sir, invalid
With
state.
the help of 4 bit, it is an invalid state. With the help of 8 bit, it is possible.
Okay.
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 With
So
the-
what should we do when it will go to the 10, 11, 12, 13, 14, 15? Every time it all values will be show 0. So if all values will be 0, it shows that it is an invalid state.
Okay. Got it, sir.
Clear?
So, sir, for invalid state, can we write don't care?
if any of the input output bit is not a 1, if any of the output bit is not a 1, in the decoder itself is the invalid state. Okay, for the representation I can write it is a x, but what is the meaning of this x when we check with the like you have a multimeter? Okay, you check 0 by the voltage, VCC is 0 volt. You check 1 by apply, check the voltage is 5 volt. But how you check the x don't care condition in the multimeter? Is it possible?
Not possible.
No. Okay, so in the written it is automatic. If I say that in the written part it is the invalid state, but the decoder, in the decoder either you apply from 0 to 9 every particularly any of the output will be 1. But if no output will be 1, it is automatically defined as a invalid state. Okay. Yes, any doubt?
No, sir, no.
Okay. Now, what should I do in this scenario is that if I take these B, C, D, ORing of this B, C, D, okay, ORing of this B, C, D, and ending with the B, C, D, and ending with the A, not sorry, BC, not BCD, it's BC, ORing with the B and C, and ending with the A. Okay, so this circuit always gives the output 1 for 1010 to 1111. You can check this one also. So 1010, 1011, 1100, 1101, 1110, and 1111. Okay, so BC, ORing of this one is 1. Multiply with ending is with 1 is 1. ORing of these two is 1. Ending with 1 is again 1. ORing of BC 1. Ending with the A 1. ORing of BC 1. Ending with A 1. ORing of BC 1. Ending with A 1. ORing of BC 1 and ending with A is 1. Okay, so for all particularly 10 to 15, this particularly circuit will gives you the output 1. Except this particularly condition, it never gives you the output 1. You can check that also, like for example 7, 0, 1, 1, 1. For the BC, it is a 1, but it is a ending with 0. Output is 0. You can check 8, 1, 0, 0, 0. For the BC, it becomes 0. Ending with A is 0. For 1, 0, 0, 1. For the BC, it is 0. Ending with A, it becomes 0. Okay, for 0, 1, 1, 0. For the BC, it becomes 0. Ending, sorry, BC, it will become the ORing is 1 and ending with 0 becomes 0. So for every particularly values and every particularly binary values that lies from 0 to 9, this particular circuit gives you the 0, and for 10 to 15, this particular circuit will give you the 1. Okay. Any doubt? Yes, any doubt? Yes, any doubts? Shall we go ahead?
No doubts.
Okay. So I can use this circuit is like in this form that, oh sorry, it is a 16. 4 plus 16 is available. So we have A, B, C, and D. Okay, MSB is Either you are taking this is the MSB, so A, B, C, and D. If you are representing in this way, it is a B, C, D. If you are representing in this way, it is a sequence is different. Okay, or I should mention this one as a input I3, I2, I1, I0, that is A, B, C. Now with respect to this one, we have a output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and there is one enable pin is available. In the decoder, one enable pin is available. Now if I create this circuit ABCD that we have already designed, okay, A, B and C, ending the ORing of these two, okay, ORing of these two and ending with the A, okay, and invert them and connect it with the enable pin. So when for 10 to 16, 10 to 15, this becomes 0. Why? Because here it will be 1. We are using the NOT gate, so it becomes 0. Now 0 connected with the enable, so basically this reset the decoder, or basically we can say that disable the decoder. Disable the decoder. And if it is disable the decoder, so for Y0 to Y15, that is output all becomes 0. All becomes 0. Okay. So this is your binary to the BCD decoder. Clear?
Means, sir, from 10 to 15, it will get disabled.
Yeah, it will be disabled. Or we can say the don't care condition. This is not given any output. Okay, so it is, so 10 to 15 will be the disable states.
But from 0 to 9, it will work
Yeah, it will work
smoothly.
as a BCD.
Okay, sir.
Okay. Any other doubts?
B and C connected to OR gate, sir.
B and C connected to the OR gate. Okay, we design the circuit here. B and C connected with the OR gate, and it will be connected with the AND gate of the A. It is the same circuit we are using. Okay, any doubts? Any doubts? So in this way, we can design the different circuits used with the help of encoder, decoder, similar to the mux, demux. Okay. Now we can use some questions. Okay, and we practice that how we design this particularly with the mux or with the encoder. Okay, we can use both. Similarly, if I give some questions, so how we design this with the demux and the decoder. Okay, now we club all four parts. So first thing is that We explain the mux part. We solve the question related to the mux. Then now we explain the decoder and the encoder part. Okay, if you clear that concept with the related to the encoder decoder, now we are clubbing these 4 things. Is it? So in the next class we will cover that one.
Okay, sir.
Yeah. If you have any doubt, you can ask.
So for the encoder, there are no conditions, no? Like for the decoder, the condition was that from 10 to 15, it is an invalid state. So
Yeah.
we use this
In
disable.
the case of encoder, what we do? We are
We
basically grounded. We are
disable
grounded
to
0
binary.
to 10 to 15 as a grounded. Okay, if we design the encoder part, so what we do, we are basically connected 10 to 15 input pins as a grounded. So they, when no output, no input is 1 in between 10 to 15, we are not getting any particularly binary number with respect to this.
And there are no conditions for encoder, no? As it converts decimal to binary.
Yeah, decimal to
Is there
binary,
any?
no condition. Okay, we are talking about the decimal to the binary to the BCD or BCD to the binary.
Yeah, so that is the decoder, no?
That is a decoder. Okay,
Yeah,
now if
and
I implement this same thing with the encoder also. So in the encoder, what we decide, we develop, we convert the BCD code into the binary. Okay. Now in this
yes,
case,
sir.
what will be the happen? What will be the happen? We are having the 16 pins and 4 as the output. Okay, my drawing is very poor, so don't. Okay, so if I say I have a 16 input pins, and 4 as the output. Okay, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 input pins and the 4. Now if I am talking about the BCD, okay, BCD to binary conversion. So the maximum possible output that is coming at the output is 1001. Then it is a BCD to binary. Okay, so what should I do? I just mentioned that I0, I1, I2, I3, I4, I5, I6, I7, I8, I9. I9. Okay, and from I10 to I15, I just combine these all inputs and grounded it. Okay, so only I615 to I10, then I9 to I0. Only here, what will be the happen? Initially, one time I0 is 1. For the second time, I1 is 1. For the third time, I2 is 1. Then I3 is 1. Then I4 is 1. Then I5 is 1. Then I6 is 1. Then I7 is 1. Then I8 is 1. Then I9 is 1. But I10 to I15 is always 0. Why? Because we are directly connected with the ground. Okay, if I0 is 1, we are getting a 0, 0, 0, 0. Similarly, if
Okay.
I8 is 1, we are getting a 1, 0, 0, 0. If I9 is 1, we are getting a 1, 0, 0, 1. So that is 0, 8, and 9. Okay, but when I10 will be 1, 1, 0, 1, 0, but it is not possible. Why? Because I10 is already directly connected with the ground. So the value of I10 never be the 1. So it is the BCD, because in the BCD we only mention the 0 to 9. We are not talking about the 10, we are not talking about the 11, we are not talking about the 12. Is it clear?
Okay, sir. Yes, sir. Means initially
So
in
we
other
can
language,
design according to this pin. We can basically use this particularly I10 to I15 pins as a grounded. Connect these two.
means in the decoder language only, where we use disable for that,
Yeah,
and now here we do means we connect it to the ground.
yeah. Because the thing is that we never connect any particularly in BCD I10 is not defined. 10 is not defined. In BCD 615 is not defined. Till 0 to 9 is defined, so we can basically take 0 to 9. 10 to 15 we are disable. We basically do that, we're connected with the ground. Okay.
Okay,
And if we
okay,
are
means
talking
to
about
10 to
the,
50.
if I am talking about the decimal to binary or hexadecimal to binary, okay. So in that scenario, what should I do?
All
I
bits will
like
be
for
one.
example, la any particular pin will be one, so there is no grounding option is available. So in this case, if I convert as a decimal to binary, so I0 to I15, all pins may be one by one. Okay. Like initially in one case I0 is 1, in the other case I7 is 1, other case I10 is 1, 11 is 1, 12 is 1. Okay. So any of the pin will be 1 in that scenario. So we can define that 0 to 15 is the binary number. Okay, so it is called the decimal to binary. But if we are talking about the BCD, always remember that we stop or basically we basically neglect 10 to 15 numbers.
Okay, so means we have the problem with means in BCD. If we exceed more than 10,
More than
then we
9,
have
more than
to
9, more
more
than
than
9.
9.
So
Then yeah, then we have to make it zero. We have to make it invalid
we
now.
have to make it invalid state.
Yes, sir. I got it.
Okay. So that's
And
why
when
what
it
should I
is
do? What should I do in the if I am saying that in the input part, it is up to me. So what should I do? I have to decide that what I connect. So what should I do? I just uh, inherited all the particularly I10 to I15 bits. Basically connected with the ground. Okay. In the output part, it is not decided by me because I can only control the input. I can't control the output. So what should I do in that particularly case? We create one circuit. We design a one circuit and connect with the enable. Okay.
so can you repeat it?
In the input, it will be up to me that which pin will be 1, which pin will be 0. Okay, so if we are going with the BCD to binary or binary to BCD, when input pins are there, I connect I10 to I15 as a grounded. But when these pins are available in the output, I can't connect with the grounded. Why? Because input will be decided by the user, output is not decided by user. So we can't connect grounded.
Okay, so got
Okay.
it.
So that's why what should I do? I just create one circuit. Okay, and that circuit will be decided that which pin will be grounded. Clear?
Yes, sir, got it.
Now any doubts? Yes, any doubts? So I think shall we stop here? So thank you all.
Thank you, sir.
Yeah.
to serve.
Good night.
Good night. Good night.